Hello everyone. In today's lecture we are going to discuss about the push operation of stack data structure. In the previous two lectures we already discussed about what is meant by stack, the memory representation of stack and the basic operations of stack. And now in this lecture we are going to discuss about the push operation and the algorithm for push operation for stack data structure. But before going into the algorithm, let's first discuss about what is meant by push operation and the basic fundamental of working of stack or the memory representation of stack. So what is meant by push operation? The process of inserting an element or an item into the stack is known as a push operation. So basically when we insert new element into the stack, that operation is called as a push operation. So first let's discuss about the memory representation of stack. Stack is represented like this in a memory. This is a memory representation of stack. Right now stack is empty. Stack has only one open end and that is called as a top of the stack. And as you can see the stack is empty, so the value of top is equal to -1. So whenever the value of top is -1, that time we can say that stack is empty. So this is a logical representation of stack. Now here we are going to discuss about the push operation, means inserting element into the stack. So for example we have an array, for example integer a of 5, and the array elements are 5, 10, 15, 20 and 25. So these are the array elements. Now if we want to insert all these elements one by one into the stack, so right now stack is empty and stack has only one open end, that is called as the top of the stack. Right now stack is empty, so the value of top is -1. So first let's insert the first element into the stack and that is 5. So here we use push operation. So push the element or item 5 into the stack. So before inserting element we have to increment the top pointer by 1. So right now the value of top is -1. We increment it by 1, so top is equal to 0 and here we insert the element, first element, that is a 5. Let's insert the second element and the second element is 10. Already we have 5 into the stack. Now again increment the top pointer by 1. So the value of top is here is 0, so 0 plus 1, that is 1, and insert the second element, that is 10. When we insert new element into the stack, first we have to check one condition, that the given stack is full or not. If the stack is full, that means the overflow condition will occur. Meaning that each time when we have to insert new element into the stack, we have to first check the overflow condition. And if the stack is overflow, that means if the stack is full, then we are not able to insert new element into the stack. So right now our stack is not full because the size of stack or the size of array is 5. Let's insert the third element. Already we have 5 and 10 into the stack. Now increment the top pointer. So top is equal to 2 and our third element is 15. Okay, again let's insert the fourth element into the stack. So already we have 5, 10 and 15. Now let's increment the top pointer. So top is equal to top plus 1, means 2 plus 1, that is equal to 3, and here the element or item is 20. Again insert new element, that is a 25. So already we have 5, 10, 15, 20 and increment the top pointer by 1. So value of top is equal to 4 and here insert new element, that is a 25. Now here our stack is full and if you want to insert another element into the stack, let's say for example 30, then we are not able to insert the element 30 into the stack because the stack is already full and it shows the overflow condition. That means our stack is completely full and we are not able to insert new element into the stack. So I hope you understand this. Now let's see the algorithm for push operation. Okay, so here we are going to see the algorithm in two different ways, the two different types of algorithm. So whichever is easy for you, you can choose that, or you can write down it in paper. So first let's see the first type of algorithm. Write down the step 1, and the step 1 is, okay, so here whenever we insert element into the stack, we have to first check the overflow condition. That means we have to check that the given stack is full or not. That means check for overflow condition. Okay, when the stack is overflow, if top is greater than equal to size minus 1, then write stack overflow. For example, let's see the array size is 5. This is a size of array, or we can say that the size of stack. In stack we insert the maximum 5 number of elements. So the size of stack is 5, and here is the condition, that is top is greater than equal to size minus 1. The array start from 0, so the last value of top is 4, because we start the array index from 0. So at the fifth number of element, the value of top is 4. So 4 greater than equal to size minus 1. So the size is 5, 5 minus 1, that is equal to 4. If this condition is true, then we return stack overflow. Okay, now let's see the step number 2. If step 1 is false, that means if stack is not overflow, then increment the top pointer. That means write down top is equal to top plus 1. Okay, step 3. When we increment the top pointer, then insert the element at the top of the stack. So step 3 is insert element in the stack. So we insert element at the top of the stack because stack has only one end, that is called as a top. So insertion and removal can be performed from the same end, that is called as a top of the stack. So here stack of top is equal to x. That means let's insert the x element, for example, and step 4 is exit. End of the algorithm. So you can write down the algorithm like this, or let's see the another way of writing algorithm. So here I am going to write down the algorithm for push operation, but in different way. So here first let's start from the begin, and first we have to check if the stack is full or not. That means we have to check the overflow condition. So here write down if statement. If stack is full, then return. That means end the program here. We are not able to insert element into the stack because stack is already full. And then end the if statement. That means end if. Now if the stack is not full, then write down the else statement. If stack is not full, then increment the pointer, and that is a top pointer. Increment top and insert element at the top of the stack. That means stack of top. Here we assign the value at the stack of the top. End else, and then last end procedure. Okay, so these are the two ways of writing algorithm. This is the first one and this is the second. Here you can use any of the algorithm from both the algorithms. These are the algorithms for push operation. Let's revise once again what is meant by push operation. The process of inserting an element or an item into the stack is called as a push operation. So before inserting element into the stack, we have to first check whether the stack is full or not. That means we have to check the overflow condition. If the stack is full, then we are not able to insert element into the stack. Otherwise, increment the top pointer, because stack has only one pointer, that is called as a top of the stack. So increment top pointer by 1 and then insert element at the top of the stack. That means stack of top equal to x. For example, stack of top equal to 10 and then exit. So in this way you can write down the algorithm. I hope you understand. If you have any doubt, any query regarding this topic or any other topic, then let me know in the comment section.